It is estimated that an organization loses about 5% of its revenue due to fraud. So it's really important to manage fraud using analytical models. In this presentation, we have discussed how social networks can be used to detect fraud in a social security setting. More specifically, we have introduced the Gottschall approach.
In Gottschall, the word speaks for itself. We want to identify all members of fraudulent groups. We introduce how to create features from the network, individual features that indicate fraud, but also group features of people that are a member of fraudulent groups. In the end, we conclude with saying that social network analysis is a main contribution for future data mining models.
Can you hear me in the back, guys? Damn. Anyway, I would like to thank Philip and Bart for inviting us, for having us over here. I think this is a great initiative. Through the past few years, through the past decade, I've traveled around the world, been teaching courses for some of the well-known organizations, banks like HSBC, been collaborating with eBay, companies like Fair Isaac, and so on. And coming back to Belgium, I was always amazed by the level of sophistication, both in terms of knowledge and in terms of analytical models. And I think this is partly due to initiatives like those. I was very well pleased by this initiative, and I think it has a great potential to offer to exchange knowledge in the domain of analytics, data science, and big data. So I think this is something we can be really proud of. Anyway, today, let's see where I can move on. Okay.
It's not the place numbers we have to select.
Is it? Let me select my presentation. Anyway, so today we're going to talk about a fraud detection algorithm which Veronique and myself have developed in a research group called Data Mining Apps. I will do the first part of the presentation, and to make sure you don't fall asleep and cheer up the second part of the presentation, Veronique will take over from me. A little bit of background information about myself. This is the boring part, so I'm going to quickly run through it. So I'm a professor of big data and analytics at the KU Leuven. My research is nicely summarized at dataminingapps.com, which recently had a serious makeover. So you may want to have a visit there, look at some of the stuff. What's really interesting is that there's a lot of stuff for free on that website. You will see the PDFs of all the 10 PhDs which I have supervised. You will find some free movies of research which we are discussing, courses, etc. You can always email me in case you have any follow-up questions at the end of this presentation. And you can get the presentation for free, by the way. These are two books. The first one is a book which I published 1 year ago together with Wiley, and which surveys the whole field of analytics in a big data world. It's very application-oriented in the sense that it's not going to focus on technical stuff, mathematical optimization details, performance criteria, etc. But it's really going to bridge the gap between analytics or data science as an academic discipline and data science as an application field in risk management, in fraud detection, marketing analytics, web analytics, and so on. The second book is a book which I wrote together with Wouter Verbeke, who works here at the VUB, and Veronique on fraud detection. It actually gets into a lot more detail into the topic of this presentation. We finished writing it a few months ago. It will be available in case you would be interested from August onwards. Veronique is a PhD student of mine. She studied handelsingenieur in de beleidsinformatica at the KU Leuven. She did her master thesis with me on social media analytics. Afterwards, I decided to hire her because, somebody had to give her a job. And then she started doing a PhD in my group. She's going to finish her PhD on October 9th. You're very welcome to attend the event on the condition that if you attend the event, you ask at least one difficult question. Good. Fraud detection. Well, fraud is all around. You have different areas in which you can see that fraud is a very substantial problem. The first one is credit card transactions. Imagine that I would steal somebody's credit card, write down the credentials, put it back again. Well, that's a kind of identity theft. I can then take your credentials, go online, and start making purchases. And I can make a purchase for a huge amount, which means that most likely I will very quickly get noticed. Or I can make small purchases, hoping that I will remain unnoticed during a significant amount of time. That's a fraud pattern. Actually, those are two examples of fraud patterns. Fraud, you can also see in insurance claim fraud. Imagine that I have a few beers here at the end of this event. I drive home with my car, being a little bit tipsy, having too much alcohol, and I bump into my house. So there's damage to my car. What I could do then is I could make it look as an accident, as if it were an accident, to claim insurance money back from my insurance firm. That's a fraudulent claim. This is something that insurance firms want to avoid at all possible cost. Fraud. Opinion fraud. Think about all these websites like TripAdvisor, eBay, even Amazon, where you find those fake reviews. Fake reviews can be detected using a very interesting technique in analytics called opinion mining. There's a good friend and colleague of mine, Professor Bing Liu, working at the University of Chicago, who is actually using analytics, sentiment analysis, to detect fake reviews. It's a kind of fraud, but from an opinion perspective. Social security fraud is one of the types of fraud that we have been working on and which we will comment on more extensively in the remainder of this presentation. Now, what do you want to do when you want to figure out fraud? Well, the first thing you want to do is you want to find anomalous behavior that deviates from a trend. Now, if you want to detect behavior that deviates from a trend, the first thing you need to define is the trend, right? And the way you define the trend can be done in various ways. You can do that at the data set level. You can see a data set there. It has a couple of legitimate customers, legitimate claims, legitimate transactions, indicated with the green dots, but has one that deviates from the overall trend, from the overall pattern in the data. Now, a deviation from the overall trend does not necessarily imply fraud. At least, it should raise a suspicion. So when you do fraud detection, the first thing that you're going to do is you're going to raise suspicions. Suspicions that warrant closer investigation by business experts, by fraud analysts, by credit card fraud analysts, or tax evasion fraud analysts, etc. Besides looking at the data set level, you can also look at the data item level. That means that you're going to look at the individual observation level. You can actually call it the individual customer level. And here you can see a series of transactions made by one particular customer. But at some point, the customer got victim to identity theft. That means that somebody stole the credentials from the SIM card of the customer in a telco setting, or the credentials from the credit card, and start making transactions in the same name as that customer. And you can see those transactions being blended in quite nicely. So here you're going to try to look and find that anomalous behavior, not at the data set level, but at the individual data item level. And one of the key challenges that you have when you do fraud detection is that you want to detect Mr. Hyde. And Mr. Hyde is a person that acts like a bandit, which is actually the fraudster, and that tries to blend into its environment as smoothly as possible. Because if Mr. Hyde can remain unnoticed for quite a substantial amount of time, then he can do a lot of interesting stuff and actually fraudulent transactions. Now, how is the cycle going, right? If you want to do fraud analytics, what is the typical steps, what is the typical loop that you're going to engage in as you work out this entire business problem? The first thing is that you're going to use an automated detection algorithm. And the automated detection algorithms, not many firms have that in place yet, but it can be based upon a set of business rules. A business rule is an if-then rule that will label transactions or claims as fraudulent based upon business expertise, based upon years of experience, based upon some literature knowledge, etc., based upon common sense. Is that a bad system? That's definitely not bad. We have a lot of very smart business experts in the industry that can write down a very well-formulated, high-performing set of if-then business rules for fraud detection. But usually, you're going to try to improve that using quantitative analytics, using data science techniques, analytical techniques, such as descriptive analytics, peer group analysis, breakpoint analysis. We describe that in our book. At least I need to make some commercial for it. predictive analytics using any predictive analytical technique. And I was recently asked, what is my top 3 of predictive analytical techniques? My top 3 is 1, logistic regression, surprise, surprise. 2, decision trees. And 3, random forests. We can talk about that later on as well. But anyway, these are techniques that you can use to label transactions claims as fraudulent. Or if you want to do it more advanced, you can do it using social network analytics. That will allow you to detect fraud. I should actually be a little bit more precise there. It's not fraud detection, but it's going to raise suspicions. Those techniques are going to raise suspicions. They're going to flag claims as potentially fraudulent. But as I told you, those suspicions should be investigated closer by a fraud expert, by a fraud analyst, a credit card analyst, an insurance claim analyst, somebody who knows the business through and through and can figure out whether the fraudulent, the anomalous observation is actually fraudulent, yes or no. And once the fraud has been confirmed, it can be fed back to the algorithm, because the algorithm needs to continuously update itself. That's something we often refer to as incremental learning. It needs to learn from the new types of fraud mechanisms which are being used by the fraudsters, because fraudsters are very smart people. That means that they're going to constantly try to beat the analytical models. As soon as they get detected by an analytical model, they're going to try and come up with new fraud patterns. That's one of the things you have in analytics. As soon as you put an analytical model into production, and that's actually for credit risk modeling, for marketing analytics, for fraud analytics, as soon as you put it into production, you're outdated. You're running behind the facts. But the thing is that you need to try and keep the gap as narrow as possible. Then we have the fraud confirmation, and then we have fraud prevention, and that's also very important. We want to prevent future fraud from occurring. That means that the analytical models that we're going to use, whether it's predictive analytics or descriptive analytics, should be white box. You can use neural networks, you can use random forests, but they're essentially black box, incomprehensible, opaque, unreadable techniques. Right? They're high performing. Most of them have universal approximation properties. But if you want to really figure out what's going on in a neural network or in the random forest, you can do it, and we did some research on it, but it's a lot harder to do so. Now, credit to whom credit is due. So Veronique came up with this definition of fraud, and you can immediately see that it can be criticized. But fraud is an uncommon, well considered, imperceptibly concealed, time-evolving, and often carefully organized crime which appears in many types and forms. Fraud is uncommon. In the data sets that we have been analyzing, we have typically less than 1% of the transactions, whether it's claims, whether it's credit card transactions, that are fraudulent. This is going to mess up your whole analytical learning phase. If you're building a decision tree, the impurity, the entropy in the data that you start off with is already quite low. So the decision tree will say everybody's non-fraudulent, because then it reaches a classification accuracy of 99%. It's well considered. Fraud is intentional, right? It's somebody with malicious intent that is actually going to try and typically steal money from you in a creative way. It's imperceptibly concealed. This is the Mr. Hyde principle. Mr. Hyde tries to blend into his, let's make it gender neutral, or her environment so as to remain unnoticed as long as possible. It's time evolving. I told you that when you deploy an analytical model, you're constantly running behind the facts. That means that the fraudsters are going to try to continuously outbeat your analytical model by devising new fraud mechanisms. It's carefully organized. Well, throughout the work that we have done, we have found fraud to be a very social mechanism. Properties of fraud detection model, they should be accurate. Accurate in terms of AUC? Area under the curve. Under what curve?
Receiver operating character.
Very good. Precision and recall are also very important numbers, like how many of our flagged transactions are actually fraudulent, how many of the fraudulent transactions did we actually capture. Operational efficiency. When we worked with a European credit card provider, we had an operational efficiency rule stating that we should make a decision, or analytical technique should make a decision, within 6 seconds after having initiated the transaction. So if you're using random forests or neural networks with lots of complex input variables that already puts a very big burden on the ICT architecture. Should come at low economical cost, and it should be interpretable or make sense. Yeah. I'm clicking on the next. Okay, social network analysis. When I say social network analysis, many of you guys think about Facebook, Twitter, LinkedIn. Please connect on those media, right? Because we use that quite intensively to disperse the results of our research and events that we're doing. But to us, social networks are more than just Facebook, Twitter, LinkedIn, etc. To us, a social network is a network of entities connected in a particular way. The entities can be anything. It could be a credit card, could be a merchant, could be a company, could be anything, right? And here you can see an example of a credit card transaction fraud social network. This is a real-life dump from a data set we got in which the blue nodes represent the merchants. The green rectangular shaped nodes represent credit cards. And then you can see the links. You can see green links indicate legitimate transactions. Red links indicate fraudulent transactions. And as you always do in analytics, the first thing that you should start off with is you should start simple. You should start doing descriptive analytics. And what is the basic way of doing descriptive analytics? That is visualization. So we visualize the network, and we look at segments of the network to see whether there's some homophily in there. Homophily means that linked entities have a propensity to belong to each other. I like my friends because they also support Club Brugge, unfortunately. I like my friends because they also like to have a good beer. So this is homophily. You find that in fraud networks as well. And the first thing that you can do is actually try to visualize and see whether there are any homophily patterns in your network. This is for social security. This is also based upon a case study which we did with the Belgian government, with the Social Security Service, and Veronique is going to elaborate more on that. Yep. Okay, so here, this is one example of social security or tax evasion fraud that we try to detect using social networks, and which Veronique is going to clarify. You can see the key company in the middle, right? This is the key perpetrator of the fraud. So what this key company is going to do is going to set up a side company 1, and actually allocate some resources to it. Resources like employees, like physical equipment, maybe even the same address, and so on. The side company 1 is going to intentionally not pay its social taxes. So it's going to go bankrupt, right? It generates some revenue, intentionally doesn't pay its taxes, goes bankrupt. Once it went bankrupt, the key company is going to take the resources, whatever they are, and start a new company, which intentionally is not going to go and pay its social security taxes again. It's going to go bankrupt, and so on. And you can see a whole web of companies that start to originate, concentrated around the key company. That's what we call a spider construction. And when we were contacted by the Belgian Social Security Service, they asked us to detect those spider constructions. So we worked out a social network whereby the nodes in the network were companies, and whereby the links were defined based upon shared resources. And we cannot tell you how we defined those links, because if we would tell you, I'm sure you would keep it to yourself, not that I don't trust you. But anyway, if that knowledge would become available to fraudsters, they would start devising new mechanisms. But if I say shared resources, you can think of shared employees, shared members of the board, shared members of the board of directors. You can think about shared equipment. You can think about shared addresses, and so on. And it's precisely this type of fraud that we try to detect with our method Gotch-All, which Veronique will elaborate on in more detail.
Okay, everybody in the back can hear me? Okay. Good evening, my name is Veronique. I always bring Bart to do the easy stuff. I will do the more tougher stuff because, yeah, he's a professor. He doesn't understand everything we're doing. What I'm going to tell you about today is about one of the most recent techniques we developed, and it's called Gotch-All. And actually the word speaks for itself. We want to detect all members of a fraudulent group. Now, the first question you can ask me is it relevant to detect groups? Well, actually when I started my PhD, I tried to detect individual fraudsters. And this is quite necessary to detect them, especially for social security fraud, for example, where we want to detect one company that is really likely to commit fraud in the future. Now, like Bart explained you, these companies are often part of what we call a spider construction. If we just identify one fraudulent company, we can stop that company of committing fraud, but of course that won't stop the spider construction to expand. So that's why we developed a new approach called Charlotte. And does this have other applications than social security fraud? Well, yes. And one of the nice applications, I think, is credit card fraud. So we did some introductory studies for credit card fraud. Unfortunately, I cannot show you the results, so you have to I will present you the results of the Social Security Institution, but this is how it works. So we have stores, merchants, the blue nodes in this subgraph, it's a fraudulent subgraph, and we have the credit card holders. These are the yellow nodes. Like Bart explained it, there is a red line between a store and a credit card holder, it's a fraudulent transaction. If it's a green line, it's a good transaction, or a seemingly good transaction. Now what do we see that often happens is that when there is a fraudster, he will use your credit card always in the same set of stores. I'm not going to say that it's exactly the same set of stores, but there is some overlap in the stores where he uses or she uses the credit card. Now if we're able to detect this kind of community, of group of stores, where a lot of fraudulent transactions occur, and we have a new credit card that is used in some of these stores, we can raise a flag. And we can have our customer service calling the customer and just ask, hey, is there something wrong with your credit card? Did you use it in this store? And then we'll know. Now, unfortunately, I cannot show you the results on the credit card fraud detection application, but I can show you the results of social security fraud. Actually, it's exactly the same, it's just another application. What happens in social security fraud? Well, we have a lot of companies, and companies, they use what we call resources to perpetrate their activities. What are resources? Like employees, like physical equipment, like addresses. Yeah? Every company has an address. And lots of other things. Now these resources, what we see is that once a company is filed for bankruptcy, that these resources move towards another company. Is this normal behavior? Yes. Because if a company files for bankruptcy, of course employees will start searching for a new job. Buyers of a certain company will look for other suppliers. So this is normal behavior. Unfortunately, fraudsters use this kind of normal behavior to blend into the surroundings. So here we have a subgraph of a spider construction where we have a bunch of resources. These are the orange nodes in the middle. And these resources are used by a set of companies. Now the companies are the red and the green nodes. A red node means that the company is fraudulent. A green node means that the company is still active and still assumed to be good. Now these resources move from one company to another company. And like Bart explained, they always move from one company to another because the company filed for bankruptcy. They're not able to work at that company anymore. Now this is a spider construction that is already detected by the experts of Social Security. Now we have other subgraphs where we do not have these red nodes. Yeah, we do not have these fraudulent companies. We only have bankrupt companies. These are the gray nodes in the network. And this is exactly what we want to detect using our Gotchal approach. Detecting groups in a network that act suspiciously. Because these are bankruptcies, but they're really closely clustered together. Now, of course, there can always be one company that goes bankrupt, and then the employees, the address, the buyers, they move towards another company. But if there is a whole set of bankrupt companies which are used by many of the resources, yeah, it's not normal anymore. And this is exactly what we want to detect using our approach. Now, how does our approach work? Well, it has 4 steps. The first step is the individual scoring. Because what do we know? We know that certain companies are fraudulent. But we do not know anything about the other companies. We also do not know anything about the resources. So if we can extract an individual score, we already have some suspicion of certain companies and resources. In a second step, we're going to detect the clicks, and using the individual scoring, we're going to score the clicks. And then we're just going to move towards traditional data mining. So that means we're going to extract features and we're going to derive a model. Now let me go through it step by step. So the first part is individual scoring. How do you have to understand this? Well, actually we treat fraud as a virus. And let's assume that the guy with the blue shirt is the source of a virus. Now I would say that many people in his surroundings are infected by the virus. And that's exactly how we treat fraud. If you're in the close neighborhood of the source of fraud, you have also a high likelihood to be fraudulent as well. However, if there are many paths to you from different sources, you're also highly infected by fraud. And we also say that our algorithm is dynamic. Why? Because fraud is dynamic. Fraud evolves over time. If you were good yesterday, I'm not sure that you're good tomorrow. So this is something we have to take into account. How do we take that into account? Well, we weigh our spread of fraud. If you committed fraud 5 years ago, you have a less explicit effect than if you committed fraud yesterday. Now, what are the results of individual scoring? They're actually quite remarkable. So in the end, we get a fraud score for each node in the network. That is for each company, but also for each resource. This is the graph of the resources. And on the x-axis, we plot the presence of a resource in fraudulent companies. On the y-axis, we have the fraud score. Now, there is a positive relationship, meaning that the more you're involved in fraudulent companies, the higher your fraud score is. Now, we have 2 really remarkable effects. The first effect is anticipating effect. These are resources that were never involved in a fraudulent company. Yet, they get a really high fraud score. How is that possible? Because maybe they're not directly impacted by fraud, but in their indirect neighborhood, there are many ways of sources to infect them. So they get a high score and we can anticipate future fraud, future suspiciousness of them. On the other hand, we have forgiving effect. And a forgiving effect means that you're not really hard. So maybe you were involved in some fraudulent company 5 years ago, maybe 10 years ago, but we forgive you for your mistakes. And this is also what our algorithm does. After a while, because our algorithm is dynamic, after a while, your fraud score decreases. As long as you're not infected by new sources of fraud, your fraud score decreases over time. Okay, after we have our individual score, now it's the most, I think, computational, expensive part of the algorithm, and that's the click detection. And the click detection is actually what we do is we combine companies. We combine companies based on the same resources. For credit card fraud, this is we combine stores based on the same credit cards that are used there. And we have 2 types of clicks. The first type of click is a complete click. That means that we have a set of companies, and this set of companies share the exact set of resources. On the other hand, we have partial clicks. where not all companies share the exact set of resources, but share a part of the resources. What is the difference? Well, for complete clicks, we just merge them into one click. For partial clicks, we also merge them in one click, but we keep separate clicks, because we know that certain members of the click are more intensely connected than other members. And then we do some scoring. So for each click, we ask some questions. How many bankruptcies are in your click? How many frauds are in your click? What about individual scoring? Because remember that we have some anticipating effect and a forgiving effect. What about the average scores of your members of the click and so on? And then we do the traditional data mining. We just derive features for each company to detect companies that have a high priority to be investigated, but also groups of companies that have a high priority to be investigated. However, we take into account on which time window. If we want to detect companies on a short time window, that means companies that are likely to commit fraud on a very short term, and companies that are likely to commit fraud on long term. Of course, it's more important to detect those companies that will commit fraud on short term. Now, we derive some features and we identify three sets of features. The first set of features are intrinsic features. And these are actually the features that occur in isolation. I do not need any network analysis to compute them. What are these kind of features for companies? Well, this is age. The age is not influenced by networks. The sector is also not influenced by the network. Financial statements are also not influenced by the network. A second set of features are the relational features. This is actually the individual score, because it's also very important on how the company as an individual acts in the network. And then a third set of features are the click-based features. Features we derive from the network. Now I have some really nice examples for you. And the first one is this click. This was one of the most important clicks that were detected by our algorithms. Now this is a click of 3 resources and 12 companies. 9 out of 12 companies are already fraudulent. 2 companies are bankrupt. Just normal bankruptcy. Why is this normal bankruptcy? Well, there is a high likelihood that inspectors missed these bankrupt companies and will classify them as fraudulent. Now this click has 1 active company. What do you think will happen with this active company? It goes bankrupt, and after 1 year, indeed, fraud is detected. Now, let me make a side note. This is based on historical information. So, I know which companies will go bankrupt, which companies are fraudulent in the future. Yeah? This company was detected after it committed fraud, because they couldn't or they hadn't these algorithms by then. If they would have used these algorithms now, they could prevent this company from committing fraud. Another example is this one, because the previous one was actually a detected spider construction. Inspectors already knew about that spider construction. This is a new one. This is an undetected spider construction because it consists of 2 resources and 5 companies. 4 out of 5 companies are bankrupt. They were not labeled as fraudulent. However, I would say that this is quite suspicious if there are 2 resources moving from one company to another company, leaving a trail of fraud. There is 1 active company. What do you think will happen with this company? Well, after 19 days, it filed for bankruptcy. And this was listed as high priority on short term. And this is extremely short term, of course. So if you want to have more technical details on the results I showed you today, because these are more global, general results, I suggest that you read one of our papers we wrote. If you just add on Google Bart's name and my name, you will definitely find this paper. And in August, we have one of our books coming out. It's already on Amazon, so if you want, you can pre-order it. The Gottschall approach, as well as individual fraud scoring approach, are explained there. So if you're interested in that, it's available on Amazon. And well, that's all I have to say today. I hope you enjoyed our presentation, and if there are any questions, the floor is open.